Alright, lesson 5.5, we're going to be talking about the rational root theorem and using it to help us solve equations. What does the rational root theorem say? Well, it essentially tells us that there is a limited number of possible roots for a given polynomial. Alright, so there's only certain roots that the polynomial can have. And we determine what those possible roots are by taking the following. We take the factors of our constant term and we divide it by the factors of our leading coefficient, and then we're going to develop a list, and that list is our possible rational roots. Alright, so let's begin. We look at 2x cubed minus x squared plus 2x plus 5 equals 0. Alright, so the constant term is 5. So we're going to write down the factors of 5. So plus or minus 1 and plus or minus 5 are the factors. Okay. Now, the factors of the leading coefficient. The leading coefficient is 2. So the factors are 2 are plus or minus 1 and plus or minus 2. Okay, so now we got to develop our list. So to develop our list, we're going to take plus or minus 1 and divide it by plus or minus 1. So plus or minus 1 divided by plus or minus 1 is plus or minus 1. Then we're going to take plus or minus 1 and divide it by plus or minus 2. And that's going to give us plus or minus 1/2. 1 over 2. Then we're going to do plus or minus 5 and divide it by plus or minus 1. So 5 over 1 plus or minus 5. And then finally, plus or minus 5 divided by plus or minus 2. That is going to be plus or minus 5/2. Okay? And so here are the possible rational roots for that equation. Okay? And when we say roots, those are also the solutions, those are also the x-intercepts, those are the zeros, they all mean the same thing. Okay, problem 2, we're going to kind of put everything together. We're going to put together why synthetic division is important from 5.4, and then why the rational root theorem is important to help us solve polynomials of higher degree. Okay, so we have a degree 3 polynomial here, 15x cubed minus 32x squared plus 3x plus 2. The first thing we are going to do is find the list of possible rational roots. Alright, so we're going to take the factors of our constant. So our constant is 2. And we'll do it up here. And so the factors of 2 are going to be plus or minus 1 and plus or minus 2. And then the factors of 15, we're going to divide that by the factors of 15. So plus or minus 1, plus or minus 3, plus or minus 5, plus or minus 15. Alright, so our list, so 1 over 1, plus or minus 1, 1 over 3 is a third, so plus or minus 1/3. 1 over 5 plus or minus 1/5. 1 over 15 plus or minus 1/15. And then we have 2 over 1, so plus or minus 2. 2 over 3 plus or minus 2/3. 2 over 5 plus or minus 2/5. And 2 over 15 plus or minus 2/15. Alright, so there is our list of possible rational roots. Now, I just want to find what one of them is. Okay? I want to find what 1 is, and then in doing so, the result will give us a quadratic equation that we're going to be able to solve for using the quadratic formula. Alright, so we have to just, honestly, we just have to test. So let's look at plus or minus 1 is something that we can easily test, plus or minus 2. Alright, so let's see if 1 is a rational root. So I'm going to take 1, I'm going to put it in the box, and then I'm going to put, I'm going to divide synthetically. So 15, negative 32, 3, and 2. So bring down the 15. 1 times 15 is 15. And then add negative 32 and 15. That's going to give us negative 17. 1 times negative 17 is negative 17. Add 3 to it, and you get negative 14. 1 times negative 14 is negative 14. 2 and negative 14 gives us negative 12. Now, 1 is not a root because we do not get a remainder of 0. So we go and let's try negative 1. So 15, negative 32, 3, 2. Bring down the 15, get negative 15. This is not going to work, so we're going to get negative 47, positive 47, 50, negative 50, negative 48. That is not 0. Okay, so plus or minus 1 is not a rational root. It's not a solution. All right, let's go for positive 2. Okay, so as you can tell, finding the solutions or rational roots by hand for higher degree polynomials is not fun. So 15, 32, 3, and 2. Sorry, negative 32. Alright, bring down the 15. 2 times 15 is 30. Negative 32 and 30 is negative 2. And then we're going to get negative 4. 2 times negative 2 is negative 4. 3 plus negative 4 is negative 1. Aha! 2 times negative 1 is negative 2. 2 minus 2 is 0. And this is huge. So we know that x equaling 2 is a rational root. Okay? Alright, now, what do we do next though? Alright, because there could be more. Well, what is left? So, if you recall, this right here is your remainder. Right, so since we have a remainder of 0, we know that x equaling 2 is a root. This negative 1 is your constant. This right here, negative 2, is the coefficient for your x. And the 15 is the coefficient in front of your x squared term. So what we have, what we can say is that 15x squared minus 2x minus 1 okay, that also is a factor of this polynomial. Alright, so let me kind of show you this way. So what we know is that if we take this, 15x squared minus 2x minus 1, and we can multiply it by, so we know that x equaling 2 is a root, so we know if we get the 2 on the same side as the x, that x minus 2 is a factor. So this degree 3 polynomial can be rewritten in factored form like this. So this, we already have one linear factor. It's x minus 2. Let's find, or let's take this quadratic and break it up into a product of linear factors. Right, so in order to do that, we'll factor that quadratic. So we are looking for factors of a times c. So 15 times negative 1. So factors of negative 15 that sum to negative 2. That sum to your b. Alright, I'm going to have to create a little bit more space, so I'm going to erase this right here. We're done with that. And, okay. So, factors of 15, 1 and 15, 3 and 5, they have to be factors of negative 15, so one's got to be positive, one has to be negative. We're going to make the 5 negative, because if you add those together, you're going to get negative 2. Alright, so we're going to take the 3 and we're going to write it over our a, which is 15. And then we're going to take the negative 5 and write it over 15. And we want to reduce these. So we can divide this top and bottom by 3. So it's going to give us 1 over 5. And then we're going to reduce this. We can divide top and bottom by 5 and get negative 1 over 3. So now we're ready to write this as the product of two linear factors. We look at the denominator here. It's a 5. So the 5 gets paired with an x. So we're going to have 5x plus 1. And then we're going to have 3x minus 1. And then we have our x minus 2 equals 0. So now notice, all of these are linear. The next thing we're going to do is set them all equal to 0 and solve. So we're going to have, I'm going to use a different color. We have 5x plus 1 equals 0. So we're going to subtract 1 from both sides. So we have 5x equals negative 1. Divide by 5. So x equals negative 1/5. There's a root. Now notice that negative 1/5 is in my list. All right, let's do the other one. 3x minus 1 equals 0. So we're going to add 1 to both sides. So we get 3x equals 1. Divide by 3. X equals 1/3. X equals positive 1/3 is in my list. And then finally, we have x minus 2 equals 0. We already solved this because right here, when we tested 2, we got a remainder of 0. So x equals 2 we know. If we add 2 to both sides, we know that x equals 2 is also a solution. And so there it is. So we came up with this big list. Alright, and what we did was we just had to kind of plug and chug to find one root. And we did that by synthetically dividing. We eventually, on our third try, when we divided through by our a, which was 2, we got a remainder of 0. Okay. Then we took the polynomial and we factored it. So this polynomial here was a quadratic. We then factored, we wrote the quadratic in factored form, and then we set each of these factors equal to 0 and ultimately solved for all of our rational roots. So I know this is a lot. These problems are not fun to do. The higher degree, finding roots for higher degree polynomials is not fun. It's a long process. I expect you guys to have some questions on this. I wanted to just put a video out there. I wanted you to take guided notes on this just to expose you to it. We are obviously going to practice this much more in class and get better at it. Also in class, I'm going to do a couple more examples for you, so you're comfortable with this. So if you're a little bit confused, that's kind of to be expected. All right, this is not an easy lesson. Just know that in class, I hope to alleviate any questions that you have, and we're just going to have to practice this. Okay, so that'll wrap up lesson 5.5, and we will see you all in class tomorrow.